Let's take a look at the MFD, the multifunction display in the Garmin G500. The MFD has a series of chapters and a series of pages within each chapter. In this case, we're looking here at the map chapter, and there's 3 pages in the map chapter as indicated by these 3 little rectangles, and the current page we are on is indicated by a blue rectangle. So we're at the default map page, or navigation map 1. If we put the little cursor on the MFD cursor knob to the right, we're going to go to the next map over, the next page, and then finally the 3rd page. In this case, we're on nav map 1. We can choose to set a range. We'll see the distance here located in the lower right hand corner of the screen. We can choose to set any map setup parameters by hitting menu, enter. We can choose the map group and have these series of preferences, or we could choose to set up the aviation group and have these series of preferences. Push and hold clear. I'll get out of here, and once again I'm on nav map 1. I can range out, and I can choose to declutter. Right now I have lots of road information, town information, all airspace, all airports, navigation aids. I'll click declutter 1 level down. Now I've lost all my road information, but I still have VORs, I still have airspace, airports. 1 level down from there, the airspace has been removed. I just have airports and any nav aids associated with my route of flight. And lastly, now all I see is my route of flight, in this case my departure airport, my waypoint, and my destination airport, and terrain information. I can choose to select this map soft key, and I can choose to toggle on or off topographical information, as well as toggle on or off terrain information. All I need to do is move the little cursor to the right, and now I'm choosing my 2nd map, my navigation map 2, and I can set whatever preferences I want for this map. So really, having nav map 1 and 2 are a tool for situational awareness and for pilot preference to assist you in your flight. The next page over would be a terrain proximity page, so you can choose to just look at terrain proximity. We can choose by this soft key to have a 360-degree presentation, or we can select this soft key here and have an arc presentation. On both of those presentations, we can select the range we want, or as we demonstrated earlier, we can simply overlay terrain information on top of our nav map 1 and 2. If we had TIS in the aircraft and that's installed, TIS would also be a soft key, and you could choose to overlay that information on top of either nav map 1 or 2 or both. The next chapter we'll deal with in the MFD is the AUX chapter. And in the AUX chapter is where we can set some system setup preferences. We can set display brightness. Normally it'll be left in the auto mode, but if you choose to dial the level down for a night flight, which is recommended as these displays can be very bright, it will automatically sequence from an auto mode to a manual mode. You can choose to toggle your V-speeds on the PFD on or off. You can choose the wind vector that you wish to have displayed on your PFD, and you can modify any date or time preferences or display units. The next the next page that we'll deal with in the AUX chapter will be the system status page. We'll get information about the line replaceable units, as well as information about the database cycles. So we'll click database, and then we can simply scroll down, verify that all the database information that's been installed in this particular setup is current, correct, and we have any information we need there. The next chapter we'll deal with is flight plan chapter. From the flight plan chapter, we'll see we have the active flight plan information. We see any waypoints associated with this flight plan. We'll see current waypoint route. We'll see estimated time en route, desired track, estimated time of arrival, and we can choose to modify any of those fields simply by clicking menu, change fields, and then we could change fields as appropriate. Here we also have the opportunity to set minimums simply by pushing that cursor in, using the big knob to scroll to the altitude field, and then use little knob and big knob to choose the appropriate minimums for the instrument approach you're about to fly. Once you've selected the appropriate altitude, simply hit enter. Now that altitude is preset into the PFD altitude tape available when you shoot the approach. As you approach, in this case 300 feet, you'll see a little bug approaching 300 feet, and when the altitude tape reaches 300 feet, you'll hear a call out minimums. Active leg information is here. The next page over will give us information about our destination. In this case, because it's in our flight plan, we see a destination information. We can click the soft key down here on the lower left of the MFD for any information about that facility, runways, name, frequencies, and all you have to do is push that cursor in. You can toggle around to get scroll down for more information. The last page in the flight plan chapter is the charts page. We have the ability here now to see charts for any airport, and specifically for airports we're planning on using as we fly in our flight plan. So once I'm here, I basically push the cursor. I need to select first with this soft key. I need to select the airport for which I want to have information presented. In this case, it's defaulting here to the airport where I'm currently located and where I'm about to depart from. I can push the little cursor to the left. I'll get a toggle here for flight plan if I want to choose any of my airports in my flight plan, and then I could scroll down and select those. Once I'm in this drop down menu, I can choose nearest, or I can choose any recent if I've selected any recent airports. In this case, let's say I want to navigate to the airport on my flight plan. Cursor down, hit enter. It's now going to load the airport diagram by default for this airport. Let's say I didn't want to look at the airport diagram, but I actually want to look at an instrument approach. The cursor is up here on this field. Simply push the cursor to the right, little knob. We'll have a drop-down menu now of all the instrument procedures, departure procedures, minimums, takeoff minimums, and any instrument approaches. Simply scroll to the one I wish to see and hit enter. We'll see the full page presentation. In this demonstration, we see it as a NACO chart. If we have JetView installed, which we will, this will be a Jeppesen approach plate. To zoom in, I simply need to just range in. Now that I've ranged in, I may want to navigate around the page. In order to do that, I push the cursor. I see a scroll bar on the right and a scroll bar on the left, and then I just use the cursor knob here, left and right, to navigate around the page to find the section that I wish to view. Once again, I can continue to range in so that I have a good presentation and I have good information in front of me. So that's the chart page. Once again, the charts are going to be all the way with this knob all the way to the right, and with the little knob again all the way to the right. So if you ever get lost, how do I find a chart? All the way to the right, all the way to the right. If I ever need to get back to my default map page, it's all the way to the left, all the way to the left. Or if I'm somewhere else, once again, push and hold clear, then it'll get me to my default Navmap 1 page. That's a basic overview of the Garmin G500 MFD. Let's take a look at the power-up sequence for the Garmin GNS 500, or the G500. I'm going to go ahead and turn the master on. We see the system will initialize. We're going to be presented on the MFD with information about the database, the GDU version, in this case part number, and every database in here, the base map land, the SafeTaxi terrain, airport terrain, etc., will be listed here with expiration dates. So during the pre-flight checks, we're going to verify that the database information is current, and then once we have gotten back to the airplane after we've done our exterior pre-flight, we will check it again. Now, the Garmin 500 won't have additional information, GPS information, until the avionics system is turned on, the radio master is turned on. So we'll go ahead and we'll acknowledge the the reference page here for the database information, either by selecting this soft key or by selecting the enter button. Once again, we'll have no GPS position information until we power up the Garmin 430, which will, once the satellites are acquired, which will present the information to the Garmin 500 PFD and MFD respectively, to allow us to navigate, allow us to receive air data information, AHRS information from the various sensors throughout the aircraft. So all we have to do, I'm gonna, on the GNS 430, I'm gonna select OK to verify once again the database information for the 430. And we start to see, as the satellites get acquired and the air data information and AHRS information is received from the various sensors to the Garmin 500, we see additional information start to present itself. In this case, I'll hit OK again. So basically what's happening is the system is locating us, geolocating us, and stabilizing any altitude or airspeed information that was that's in the system. So that's the basic power-up sequence for the Garmin 430, the Garmin GNS 500, and once the system is started, we'll start to look at an overview of the PFD and the MFD. Let's take a look at SafeTaxi in the Garmin G500. Navigate to the default map, or the nav map 1, and all you need to do to access SafeTaxi is simply continue to range in. As you range in, you'll see that the airport will go from a generalized depiction of the airport to a more and more detailed representation of the airport geographic information. The farther you zoom in, the more information you'll see. In this case, we start to see runway numbers. We see buildings located around the airport. And as we zoom in, we start to see, okay, in this case we see the Gulf Taxiway, the Delta Taxiway, Bravo 3. So as you navigate around the airport, and we're going to just move the demo aircraft here, you'll see that you're able to follow along and ensure that you are complying with all taxi instructions and have a good situational awareness of everything happening around you, and ensure that you comply with all taxi instructions by ATC. So again, to access SafeTaxi, it's very simple. Just simply range in, and the more you range in, the more detail you'll see. You can follow along as you taxi around the airport to ensure you are aware of your surroundings. SafeTaxi, Garmin G500. let's look at turns in the PFD and how they'll be presented. I'm going to use the autopilot for this particular simulation. Select heading. I'm going to make a left-hand turn simply by rotating the cursor for the bug knob here. I'm going to bring it around. As we start that left-hand turn, we have a trend vector show up on our HSI. And what that's showing us here, as it reaches this larger tick mark here, is a standard rate turn. So as the aircraft rolls in, trend vector presents itself. When the trend vector is matched up, the end of the trend vector matched up to that particular tick mark, that's a standard rate turn. If it's matched up to this tick mark that's halfway between the tick mark here and the center presentation, that's half standard rate turn. So we'll let the aircraft level out on 060. As it does, that trend vector will disappear back behind the center pointer for our heading indication. And now I will start a right-hand turn, and we will see that trend vector once again present itself, slowly stabilize to a standard rate turn. Our attitude indicator information up here basically again is just going to show us our bank angle. So this would be 0, this would be 10 degrees, 20 degrees, 30 degrees, 45 degrees, and 60 degrees. As long as we keep this presentation of the triangle, there's a little brick, we're going to call it, underneath this triangle that extends the sides of this triangle. As long as this brick is centered beneath this triangle, you are coordinated. If this brick slides left or right, it's basically presenting the same information you would see on an inclinometer and showing you that you are uncoordinated for that particular phase of flight. So keep this brick in the house, keep the brick centered, step on the brick, however you need to refer to it. It's doing the same information, giving you quality of turn information as an inclinometer, and it acts the same way. So once again, we'll make a right-hand turn. We'll come all the way back to 300. Standard rate turn here is presenting itself. The standard rate turn will even out with this tick mark that indicates standard rate. Again, half standard rate would be halfway. That's that mini little mark. And obviously the trend vector for standard rate will disappear if we are doing a steeper angle of a bank. The simulation in this case won't allow us to go any more than standard rate, so that's all I can show you. But that's standard rate turns in the Garmin G500 PFD. Let's take a look now at how the airspeed and the altitude will be presented on the PFD for the Garmin G500. As I increase the airspeed, we see the airspeed tape start to move. The true airspeed will be indicated here. The airspeed will move from this caution range or danger zone of any stall speed. We start to see the V-speeds that we've bugged come into view, pass through the current airspeed. We see the stall speed of the aircraft and the white arc. We see the green normal operating range present itself. If I increase the airspeed, we'll see a yellow caution range appear, as well as eventually we should see the barber pole show up, telling us we're getting into a danger zone of the aircraft. And as we get into that never exceed range, we're going to start to see the actual airspeed indication show up as red as well. I'm going to decrease the airspeed now to something more appropriate for this demo. What we have here, as you notice, is this magenta line. This magenta line throughout the Garmin 500 system and most glass systems is a trend vector. That's going to tell us where the aircraft will be in 6 seconds. In this case, we're talking about what airspeed will the aircraft be in 6 seconds. So as I increase the airspeed, the trend vector will slowly start to move up and indicate in 6 seconds that's where it'll be. And as we start to reach our airspeed, in this case we're going to go into a caution speed, the trend vector will disappear. In this case, if we've slowed down, it'll show us where we're going to be, and it will disappear back to 0. Now I'm going to increase the altitude for this demonstration, and we'll start to see the altitude tape move. Trend, again, a trend vector for where we'll be in 6 seconds for altitude will present itself. The actual altitude numbers for our current altitude will be displayed here. We see that we continue to climb, and as we climb, we have a heading bug, or sorry, an altitude bug that we have pre-selected at 4,000 feet, somewhere above our current altitude. If we look here, we see our vertical speed tape indicating a climb rate of plus 3,000 feet a minute. We only get presented up to 2,000 and then above. So it's indicating right here as plus 3,000. Our vertical speed tape, in this case we can select a bug, and we can select that bug to 0 or some climb or descent rate as appropriate. Whatever selected bug, in this case it's positive 200 feet a minute as indicated here and here. We can bring that back to 0. If we wanted to select the current rate at which we are climbing, we would simply make sure to select the vertical speed button and push to sync. Now the maximum climb and descent speed that you can bug is 2,000 feet a minute, and since we're currently doing 3,000 foot per minute climb, we can't get that far. Right now the altitude pre-select has shown up. It's slowly coming into view. The aircraft is pitching down. That trend vector for where our altitude will be will slowly disappear back to 0, and our vertical speed indicator here slowly comes back to 0. I'll select another altitude pre-select. In this case we'll roll down to 3,000 feet. We see that the altitude pre-select has moved down to the bottom of the altitude tape, and as I decrease the altitude on the simulation autopilot, you'll see that vertical speed tape start to move slowly down. In this case it's going to go down to about 3,000 feet a minute, and we see that trend vector appear. That trend vector will remain until the aircraft slows its descent and starts to level out, in which point the trend vector will disappear back to 0, and we won't see it anymore. There comes our altitude pre-select. Here comes our vertical speed slowly leveling out. It'll disappear back when it becomes 0, and the numeric presentation disappears, and here we are. We can now, if we wish, we can select vertical speed, push to sync. We'll sync whatever the current vertical speed is, and that's basic climbs and descents. I'll reduce that airspeed one more time just so you see that trend vector appear for the airspeed. We see any bugged airspeeds here, in this case VY, right at our current, just above our current airspeed, trend vector disappearing. You can see here we're in the white arc now, flap operating range for that particular aircraft model, and that's basically climbs and descents. Alright, let's take a look at a non-precision approach. In this case we're just going to look at a GPS approach, GPS runway 1 to Republic. Here we are. I've activated the approach. We're on our way to our initial approach fix of NICAD. We can see we're just in level flight here at 2,000 feet. I have my barrel minimum set for the approach, and that's right off of the approach plate. My CDI is currently in GPS mode. I have the autopilot set in this instance to GPS mode. You see that we're arriving at the waypoint NICAD. On the overlay map, we see a standard rate turn presented in front of us, so that should be the track we'll follow along the ground. The magenta line here for the current leg should switch from this line here to the next line, from the NICAD to the next approach point, next fix, as we start to navigate. And there we go. So now we're on NICAD to bland. Standard right presentation here, trend vector. We have completed our pre-landing check. We are at the correct altitude. We have our barrel minimum set. We can navigate once again to the active flight plan page, the flight plan chapter. We see all of the fixes associated with that approach. We see that we have our barrel minimum set. We see the active leg info, and we can navigate with the little cursor here to the approach plate itself. In this case, the GPS 1 can range in or out, more or less detail. We push the cursor in, and that presents essentially these two scrolling vertical and horizontal scrolling bars. We can navigate throughout the map just by moving those, moving the cursor left, right, outer ring, inner ring to navigate around. If we want to look just at the profile view and see the minimums, if we wanted to see the plan view. And in the aircraft with the jet view, we should have georeferencing. So this little airplane should be available so that if you were looking at this chart, you'd see the aircraft, in this case, right here. We don't have that in the demo mode, so I can't show that to you. But we'll continue to range in so we have an idea. Okay, I should expect the next thing to be a right-hand turn from bland to deuce, our final approach fix. So after bland, I can descend down to 1,600 feet. So what will I do as I approach bland? And we're going to see a right-hand turn coming up here in just another second. Here comes our right-hand turn. We've passed our waypoint, and we're on our way from bland. Comes up in 0.7 seconds, 0.6, desired track, actual track, as we make that right-hand turn. Once the next leg becomes active, and I know that I have overflown bland, there we go, we're on our way to deuce. I can select altitude. I'm going to dial my altitude down to the next assigned altitude, 1,600 feet in this case. I'll go ahead and clear off of this page. Again, anytime I push and hold clear, just like in the Garmin 430, we can navigate to the nav map 1. This is our default position for returning back to our home base, basically. Here we are at 1,600 feet. Continuing on the approach, pre-landing checklist is complete. All the instrumentation is set up for this approach. I could pre-select if I've calculated my VDP. I could prepare to calculate my vertical speed, and I know that for my non-precision approach I want a, we'll say, 600 to 800 foot per minute descent rate. So I could pre-bug that there so that I know in order to reach the runway with visual reference in sight in the appropriate amount of time, if I can give myself that descent rate, I will be able to see with enough time to make a normal approach to landing. Now, one thing we want to talk about here is this is a traditional non-precision GPS approach, but it has, so it's lateral navigation, LNAV, plus V. The Garmin G500 is going to give us a vertical glide slope, but it's not a true glide slope. It's not a precision approach. It's not like a localizer with precision vertical guidance, an LPV. It is a false representation. It's basically an electronically produced glide slope based on distance, and altitude. But it will be presented very similarly here with this glide slope information. So as we approach it, just like we would on an ILS, as we come in from underneath the glide slope, we're going to intercept it. Once we have intercepted it, we would begin a descent down to the final approach altitude, or the minimum descent altitude as appropriate. So here we are, we're approaching Deuce. We can see we got 0.4 nautical miles. Once we pass Deuce, our final approach fix, we would want to obviously commence a descent down to the appropriate altitude, and we'll try to take this slow, see if we can keep that glide slope in there. As well as we would want to reselect altitude. We can select heading to sync it to our current heading, reselect altitude, pre-select the missed approach altitude so it's available to us when needed, and we're going to keep descending down to the minimum descent altitude for this approach. And we have the same presentational information right in front of us. We see the next waypoint is runway 1. We see that the distance is 3.2 nautical miles. Our desired track is 013 degrees. We're actually tracking along the ground. If we were able to maintain a true glide slope for that vertical glide slope, that is LNAV plus V, we could see it here. In this case, we are just taking this as a true non-precision approach, descending down to our minimums. We see the barrel minimums of 480, and that's bugged right here as 480. And we would continue on our approach to the runway, executing missed approach or continuing our descent to landing as appropriate. So that's basically a non-precision approach, LNAV plus V. The Garmin G500 will give you an electronic glide slope information presentation, so you can follow that down to the runway, but you need to keep in mind that that it's not a true glide slope or true vertical CDI, so you need to take that into account.